Hello everyone, welcome to my channel. Now in this video we are going to learn principle of superposition. Now this is with regard to principle of superposition of waves. Now suppose you have a string, okay, and this is fixed at both ends, okay, and suppose from this side there is a pulse going in this direction, okay. So at this instant it is at this particular position. At a later instant, it will move like to this particular position, then this position, then this position, and so on. Okay, and similarly, there is one more pulse which is coming from the opposite direction. Okay, now suppose this direction, horizontal direction is x-axis, vertical direction is y-axis. So this is the x direction. Okay, so now suppose this is some position x, okay, and this wave reaches this point, this position x at time t, okay, and it produces a displacement in this direction, okay. Now this wave reaches the same position at the same time, producing displacement in the downward direction. Okay, so the net displacement will be, if the two waves, suppose they are identical, okay, in that case this at this particular position the resultant displacement will be 0, okay, and after they cross over, okay, so now suppose this is the initial instant and this is when they superimpose, and this is at a later time. So at a later time this wave is this one, this pulse is this one, so they will retain their identity after they cross over, but at the position and at the instant they overlap, the resultant displacement is the algebraic sum of the displacement of the individual waves. That is, suppose for this pulse the displacement at this particular position and this particular time, it is suppose y1. So y1 x comma t, this is displacement is a function of x and t. Now for same position and same time for this wave, suppose the displacement is y2 x comma t, okay. So now the resultant displacement y x comma t, it will be sum of these two displacement, okay. So this x and t will remain same, okay, because both the waves, this wave and this wave, should, for overlapping, so if you are observing the overlapping is at this particular position, then this wave should reach this position at this time, and at the same time and at the same position this wave should reach at this particular position, okay, then only overlapping will be possible at this particular position. At some other position you may have overlap, okay. So this x comma t everywhere it is same, okay. And the another, so first thing is the resultant displacement is the algebraic sum of the displacement produced by the individual waves or individual pulse. This is first thing about superposition. And the second thing about superposition is, after the waves, see this is superposition, and after superposition this wave has gone cross over to this side and this has gone to this side. So after they cross over they retain their properties. So these are the two essential properties or on the basis of which this principle of superposition works, okay. Now superposition of waves leads to various phenomena, okay. The prominent among them which we are going to learn in the later videos is first one is interference, okay, this we will discuss in this video. Then we have formation of stationary waves, okay, and last is formation of beats. So these are the three important phenomena which arises due to superposition of waves, okay. Interference, stationary waves, formation of stationary waves, and beats. Now in this video we are going to see this phenomena, interference. So consider two harmonic waves, y is equal to a sine kx minus omega t and y2 is equal to a sine kx minus omega t plus phi, okay. So these are two harmonic waves, okay, and they are traveling in the same direction, they have same amplitude, k is same, so it implies they have the same wavelength, omega is same, so the frequency is same, but there is a phase difference, so phi is the phase difference. So these two harmonic waves are traveling in the same direction, and suppose they are undergoing superposition. Okay, now on superposition we know the resultant displacement, it will be the algebraic sum of the displacement of the individual waves. So y is the resultant displacement produced due to superposition of these two displacements. Okay, so this is y is equal to a sine kx minus omega t plus a sine kx minus omega t plus phi. Okay, so if you add these two quantities, what do we get? Say a is common, so this is 2 sine kx minus omega t plus phi by 2 cos minus phi by 2. Okay, this sin a plus sin b, 2 sin a plus b by 2 cos a minus b by 2. Okay, now this cos minus phi by 2 can be written as cos phi by 2. So I can rearrange these terms as y is equal to twice a cos phi by 2 sin kx minus omega t plus phi by 2. Okay, now if you remember the general equation for oscillation, it was y is equal to a constant terms cos omega t or sin omega t. Okay, so there was a constant term which we call amplitude, and then this trigonometric term multiplied trigonometric term which is a function of the phase. Okay, so now if you see this equation, see this term is a constant term because this phi is a constant phase, and phi is the constant phase difference between these two. Okay, these two waves. So this phi is constant, 2 is constant, a is constant, so this entire term is constant, and this is sine kx minus omega t plus phi by 2. So this is the phase of the resultant wave, and as we can see, the initial phase of the resultant wave is phi by 2. This is the initial phase, and this quantity represents the amplitude of the resultant wave. So this is amplitude of resultant wave. This is amplitude of resultant wave. Let's see how this amplitude behaves. Okay, so now see, we have amplitude, suppose this capital A represents the amplitude of the resultant wave, so A is equal to twice A cos phi by 2. Okay, so now let's see under what condition we have maximum amplitude and under what condition we have minimum amplitude. Okay, so now this maximum amplitude will be A max will be equal to twice A, provided this term is 1. Okay, 1 or minus 1. Okay, amplitude we take the positive sign only, so that is for this term to be 1, this phi should be equal to 0, or in general I can write phi should be equal to twice n pi, where n is equal to 0, 1, 2 and so on. For this, when phi is a even multiple of pi, this amplitude is maximum. Okay, now similarly for minimum amplitude, see A minimum, it will be 0, and if amplitude is 0, this displacement will be 0. Okay, displacement of the particle will be 0. Okay, so for minimum amplitude, this term need to be 0, cos phi by 2 should be equal to 0. So that is when phi is equal to twice n plus 1 pi. Okay, where n is equal to 0, 1, 2 and so on, because if I substitute n equal to 0, so this is phi is equal to pi, so if you substitute over here, this is pi by 2, cos pi by 2 is 0. Okay, so this is under these conditions will get minimum amplitude, and under these conditions you will get maximum amplitude. So now when the amplitude is maximum, it is called constructive interference. Okay, it is called constructive interference. So this is constructive interference. Constructive interference, and similarly this, when amplitude is minimum, this is destructive interference. So now what is interference then? what are we observing here actually? See, interference, we have two harmonic waves. Okay, now what are the conditions for these harmonic waves? These waves should be identical in the same sense. They should have same wavelength, same frequency, and regarding phase difference, either phase difference should be 0, that is the two waves must be in same phase, or if at all there is a phase difference, it need to be a constant. Okay, so here phi is the phase difference between the two waves and it is a constant, it is not changing with time. Okay, now if such waves superimposes, okay, now this will form a resultant wave. Now in the resultant wave, at certain values of phi you will get maximum amplitude. Okay, and at certain values of phi you will get minimum amplitude. Okay, so now this entire phenomena is called interference. Okay, this is called interference. So interference is the superposition of waves which are identical waves having same frequency, same wavelength, but having a constant phase difference. Okay, the two waves need to have a constant phase difference or zero phase difference. Okay, so this is interference, and this is the case where we have used the amplitudes of the two waves to be equal. Okay, now what happens if the amplitudes of the two waves are different? That we will observe now. Now suppose we have y1 is equal to a1 sin kx minus omega t, and y2 is equal to a2 sin kx minus omega t plus phi. Okay, so now we have two waves where again k is same, so wavelength is same, angular frequency is same, so they have the same velocity, they are traveling in the same direction. Both the waves in this case, they are traveling along positive x-axis, and they have a constant phase difference. So condition for interference is satisfied. But here we have taken two waves with different amplitude. Okay, so now if they have different amplitude, now on superposition, the resultant wave again will have the displacement y1 plus y2. So this y is equal to a1 sin kx minus omega t, and this a2 sin kx minus omega t, this can be written as a2 sin kx minus omega t cos phi plus a2 cos kx minus omega t sin phi. So this is, I have written this in the form, suppose this is sin A and sin A plus B. Okay, sin A cos B plus cos A sin B. Okay, so now see this sin kx minus omega t, this is common. So if I take this as common, so this is sin kx minus omega t. So this is a1 plus a2 cos phi, a1 plus a2 cos phi, and this is plus a2 sin phi cos kx minus omega t. Okay, now if I make a substitution wherein I write this term as a cos theta and I write this term as a sin theta. Now why I am writing this? See, this a1, a2 cos phi, these terms are constant, so I can replace this constant by some other constant. Okay, similarly this constant is replaced by this constant. So what will happen? This will become a cos theta sin kx minus omega t. Okay, and this is plus a sin theta cos kx minus omega t. Okay, so now this can be written as y is equal to a sin kx minus omega t plus theta. Okay, see what is the advantage of writing like this, making this substitution, is initially the two waves were of the form displacement equal to amplitude sine of phase term, displacement equals amplitude sine of phase term. But when these two waves are added, we get a wave in a very complex form. But when I make this substitution, again we have displacement equal to a constant term sine of phase term. So now this constant term represents the amplitude of the resultant wave. So what is the value of this amplitude? See, here we have written a1 plus a2 cos phi as a cos theta. Okay, and this is A2 sine phi as a sine theta. Okay, so now if you square both these quantities and add, so this will be a square cos square theta, so this will be a square cos square theta, and this is a square sine square theta. A square is common, sine square theta plus cos square theta, it will become 1. So this will be a square, it will be a1 square plus a2 square plus twice a1 a2 cos phi, or I can write a as a1 plus a1 square plus a2 square plus twice a1 a2 cos phi. So this is the expression for the amplitude of the resultant wave. Okay, and where phi is the phase difference between the two waves which were undergoing superposition. Okay, now we know that, see, this intensity I, it is proportional to amplitude square. Okay, so in that case this expression can be written as I is equal to I1 plus I2 plus 2 root I1 root I2 cos phi. Okay, now when this phi, as we have seen, when phi is equal to twice n pi, this amplitude, it is going to acquire a maximum value. What will be the maximum value? A max, it will be equal to A1 plus A2. Similarly, when phi is equal to twice n plus 1 into pi, odd multiple of pi, in that case this will be minus 1. So this amplitude will be minimum, it will be equal to A1 minus A2. If A1 is greater than A2, you have to make A1 minus A2. If A2 is greater than A1, you write A2 minus A1. Okay, so this is maximum amplitude, this is minimum amplitude. If this condition is applied over here, we get I is equal to root I1 plus root I2 square. Okay, this is maximum intensity when phi is equal to twice n pi, and similarly when phi is equal to twice n plus 1 pi, that is for condition for minimum amplitude, the intensity will be minimum. I minimum will be root I1 minus root I2 the whole square. Okay, so this is intensity and this is amplitude when you have two waves undergoing superposition with different amplitude. This is the resultant amplitude, this is the resultant intensity. So this is all about interference, and based on this please try out some problems so that your concepts are more strengthened. Okay, I hope this video is beneficial to you. My best wishes to you. Good luck.